All right, let's do this first Punnett square example. I have my criteria for success that is also in your OneNote. So let's read the problem first. Brown hair is dominant to blonde hair. A heterozygous mom marries a blonde-haired dad. What is the likelihood that their kids will have blonde hair? This is a very standard Punnett square question. They give you some like dominant versus recessive information, and then they hint at what the genotypes of the parents are. So first step, determine the parent genotypes. So of course, any Punnett square question, we need parent information. They tell you that the mom is heterozygous, and they tell you that the dad is blonde. Earlier in the problem, they say that brown hair is dominant to blonde hair. They don't give us any ideas as to what the actual alleles are, so I'm just going to pick a random letter to represent. I'm going to say that B is going to be our allele letter. B or little b. Okay. So if we know that brown hair is dominant, my capital B is going to represent my brown hair. Any dominant gene is going to be a capital letter. Therefore, my little b is going to be my recessive, which is blonde. So this is the first step, is figuring out parent genotypes, and we first need to figure out what each allele means. So brown hair is dominant, therefore it is capital, and it is brown, and blonde hair is going to be my recessive gene. So heterozygous mom. So my mom is heterozygous. That means two different alleles, meaning one big B, one little b. Marries a blonde-haired dad. Because blonde is a recessive gene, the only way that it can show up is if I have two copies of the same allele. So two copies of my recessive allele, little b, little b. And these are the genotypes of my parents. Mom is heterozygous, dad is homozygous recessive, and we got that from this phenotype. So we did number 1. Number 2 is draw the box. This box looks like this. It is a square. I probably should have done that bigger, and it has 4 little squares within. How I'm going to set this up is I am going to put mom, let's see this one, doesn't matter where you put them, I'm going to put her up here. So she has a capital B and she has a lowercase b. I'm going to put dad on the other side. So dad is little b. I'm going to put him right over here. Little b, little b. And now I have to cross their genotypes. So I drew the box. Now I have to cross the parent genotypes to fill in each of these 4 boxes. How I'm going to do this is this box right here has crossed the big B and the little b. This box has a big B and it has a little b. Big B from mom, little b from dad. This box has a little b from mom and a little b from dad. This third box has a big B from mom and a little b from dad. Last but not least, this box has a little b from mom and a little b from dad. So we have crossed the parent genotypes, and now all we have left to do is just analyze the phenotypes of this. So I know that anytime I have a capital B, because it is dominant, I will always have brown. So I have a capital B right here and a capital B right here. So I know that in 2 out of the 4 boxes that I have, 1, 2 out of a total of 4, I am going to have brown hair. Brown. And I know also that in 2 out of the 4, I am going to have blonde hair because I have 2 boxes that have homozygous recessive, which means it is blonde. All right, so now I have analyzed the phenotypes, the physical traits, and I'm ready to answer the question. What is the likelihood that the kids will have blonde hair? I already figured that out right here. 2 out of the 4 hypothetical kids will have blonde hair. 2 out of 4, which is the same thing as saying about 50% likelihood. These questions are typically always going to be in percentages. So 50% chance that a heterozygous mom and a blonde-haired dad will have blonde kids.